Hello, how are you? Let's now start the last part of our lesson, Chapter 14, Lesson 2, Energy Transfer. The last thing we want to talk about in this lesson, again, we're going to talk about heat. Do you remember heat? What's the meaning of heat? It is when the energy transfers between objects which have different temperature. Okay, so when I have two objects with different temperatures, heat transfer between these objects or energy transfer. This process we call it heat, and always energy moves from objects with high temperature to objects with low temperature. Good. Now, heat raises an object's temperature or it changes the object's state. This sentence is very important and I will explain it to you. But please, I want you to focus with me to understand this process. Look at this figure, all of you. We have here a graph, temperature with time. Let's start studying it part by part. The first thing, what I have here, an ice cube. Now this ice cube, now we know that the temperature of it is less than 0. Okay? Because the freezing point is 0. So the ice cube here is the temperature 0. Look, here is 0. Now the ice cube is here, so the temperature of it is less than 0. Now if I have an ice cube and I put a source of heat under this ice cube. Okay, for example, I put it in a pan and I put a source of heat here. Fire, source of heat, candle, whatever. After that, what happens? The temperature, and also at the same time I put a thermometer to measure the temperature of the ice cube. Let's say at the beginning, for example, the temperature of it is -5 Celsius. At the beginning, what will happen? The temperature will start to increase. You will see that the ice cube is still ice, but the temperature of it starts to increase until it reaches 0 Celsius. When it reaches 0 Celsius, what will happen? You will see that this ice cube will start to melt. Now, while the ice cube is melting, the temperature will not change. So I still have fire and a source of heat, and I'm heating this ice cube. But this energy is not changing the temperature, it's changing the state of matter. It's breaking the bonds between the particles in the ice cube because it wants to change to liquid. So you will see for seconds, for 1 minute, whatever, that the temperature on the thermometer is still 0, 0, 0, and what you are seeing at the same time, that the ice cube is melting at this time. Now when all the ice changes to liquid, at this moment you will see that the temperature again will start to increase. At this moment, what you're going to see, liquid. Okay, only liquid, no ice at all. The temperature will continue increasing. Now guys, why the temperature is increasing? Because I still have a source of heat. Until what you see that the temperature in the thermometer becomes 100 Celsius. Now we know that 100 Celsius is boiling point, right? For water. So what will happen here at this moment? This liquid or this water will start to change to gas. It will evaporate. So here the temperature will stop increasing. Look, the temperature will stay 100, but at this moment you will see that the liquid starts to evaporate. It will start to change from liquid to gas. While it's changing, the temperature will not change. Put a thermometer and see. You will see that the thermometer, the temperature of it will stay 100 Celsius until all the liquid evaporates and becomes gas. So What do you understand now? You understand that heat or energy, here, where is the heat? Here's the source of heat that I put it under the ice cube from the beginning, all the time, okay? It can do one thing at the moment. It can change the temperature, raise the temperature the same as here, or it can change the state of matter. If the temperature is changing, the state of matter stays the same. If the state of matter is changing, the temperature will stay the same. Clear? Okay. Again, look here to make sure that you understood why I have solid. Here's the source of heat. While I'm heating this solid, what happens? The temperature will start to increase until it reaches what? 0 Celsius. At 0 Celsius here all the time, the temperature will stay 0 until all the solid becomes liquid. Now when all of it becomes liquid, I put the thermometer here, or I read the thermal reading on the thermometer, I will find that the temperature of it will start to increase. The reading on a thermometer will start to increase until it reaches 100 Celsius. When it reaches 100 Celsius, what happens? It will start to evaporate, but the temperature will stay 100 Celsius. It will not increase until all of the liquid changes to gas. Clear? Good. So that's all for our lesson. We're done with our lesson. I want you to solve this section review on page 487. It's homework. I will check it and I will solve it with you next week. Now, what we're going to do is to play the game together. Do you remember our game? We used to play it always after each lesson. Today, I will play it with you. How? I will start playing the game and solving the questions. While I'm reading the question, please pause the video, stop it for seconds, try to answer the question by yourself, then play it again to check your answer with me. Okay, so we will play the game together. Let's see. Okay, the first question. In some cultures, walking on fire is the ultimate sign of strength. Walking on fire, what type of energy transfer or heat transfer we have here? For sure it is conduction. We have contact, so conduction. Good. The warm air from this heater creates a current when the warm air rises and the cold air sinks so easy. What do we have here? Convection, for sure. The chocolate bunny and the blow dryer. I have a blow dryer. I have a source of what? Air. Hot air. So what we are talking about, which one? For sure convection. Hot air, cold air. So convection. The candle will slowly heat the metal and transfer the heat directly to the man's hand. What do we have here? Conduction. Thanks. We can use this later. I don't think that we're gonna need it. The baby chickens are kept warm from the heat lamps. I have a heat lamp, and baby chickens. So how they get warm from a lamp? So what? We have radiation. Lamp works the same as sun. So waves. Radiation. Which direction will the heat flow while this ice cap melts? I have here ice cap. When it starts to melt, how the heat will transfer from where to where? What do you think? From hot to cold. So from water to the iced cap for sure. In this experiment, the warm red dye and the cold blue dye was placed in the water at the same time. The warm red dye rose to the top while the cold blue dye sank to the bottom. What type of energy transfer? Hot air and cold air, hot dye, cold, for sure. Convection. The sun shines down on this family as they play on the beach. So, from the sun, radiation. No, I will not count it wrong for you. The chocolate bunny and the lamb. Again, lamb. So, radiation. Remember, always the lamb is radiation. Another game. Thank you, because you answered all the questions correctly. Good job, girls. Blow drying your wet hair. So, air, hot air. What do we say? Convection. Walking in the warm sand with your bare feet. Yes, I'm walking. There's a contact. So, conduction. For sure. Poor conductors like wood and plastic are called, for sure, what? Insulators. Johnny accidentally grabbed the handle of the hot pot. Grabbed, touched, so conduction, there's a contact. Heat transfers from an area of temperature to an area of temperature, from hot to cold, from high to low. Oh, sorry, by mistake. High to low. Okay, no problem. The Gulf Stream is a current that brings warm ocean water from the south to the north. Motion of hot air, hot warm water. So, convection. Another gap. Okay. A group of friends gather around a fire to stay warm. Around the fire, so radiation. The man goes to take the hot pot off the stove with his bare hands. To take the hot pot off the stove, look, contact, so conduction. The last two questions. The chocolate bunny and the iron. Look, iron, chocolate bunny, they are in contact, so conduction. The last question. Oh, not the last question. Which direction will the heat flow while this person holds a hot cup of tea? Easy. From where to where? From hot to cold, from hot to warm. So here, from where? From the cup to the hand, because the cup is hotter than her hand. Now it's the last question. Warm air rises and the cool air sinks. What do you think? Convection. That's all, girls. Okay, I hope that you enjoyed the game. I hope that you answered all the questions correctly, the same as me. Here's the question that I pressed wrongly on the correct answer. Here, as we said, from high to low. So here's the answer for this question. Okay, that's all. Thank you, girls.